Well, thank you very much, Volker. Thanks to the organizers of this workshop on new structures, in, for, of, and so on. And I'm talking about an outsider, how to deal with them. So what is an outsider? Usually you speak of amateurs. And if you look into the early history of Wikipedia, this is a site that has been around for about 30 years, and it only exists in 4 languages, English, and then Spanish, Turkish, and Arabic. And so you have a list, I mean, this is only part of the list, of what they call amateurs. But I show this to you because it says these are people whose primary vocation did not involve mathematics. So in order to determine whether or not somebody is an amateur in the sense of this site, you would have to determine his primary vocation. This person will come up in my talk, but I'm not going to talk about amateurs. Maybe they talk about amateurs because there's this book, but this book doesn't go very far in history. It's far before the 20th century that it's in the 19th century, first half, that it stops with Bolzano. So in this talk, rather than prying for actual vocation of a person, which a historian can never know, I guess, or hardly ever know, we shall look at mathematical outsiders in order to better understand the internal structures. So the outsider is a mirror image of what's happening inside the science, the community, and so on, and the mathematics. And if you start from the 19th century, which is sort of the stepping stone from which we go into the 20th, then these are the major events of the internal structures that change. Jobs for mathematicians, departments of mathematics were created in most universities. Specialized journals of great importance were founded. Of course, there has been some before, but not that type. And then scientific societies are created. This has been mentioned in earlier talks here before. This French one in 1872, the German one 1890. Academies also still play a role. So if you want to pry more into the 19th century about amateurs, outsiders, there is this article by Katrin Goldstein who does a very good job. And in particular, that's why I show it to you here. I have to go quickly because I have lots of other things to say. She points out that Cayley and Kronecker, in a certain understanding, were outsiders because they were not dependent on the position that they had. They just lived independently and did mathematics for fun. So then we go from the 19th to the 20th century. I added, going to the 20th century, one more journal, which will become important in a little while, this Mathematische Zeitschrift, a real Berlin journal founded by Berlin mathematicians. And then we are into the 20th century with international congresses, you know all about it. Then in the 20s and 30s, philanthropic capital, and especially the Rockefeller stipends, and the foundation of the Institute for Advanced Study as a model for this kind of institutes that house mathematical research. Specialized conferences on a national and international scale are becoming more and more frequent. This has been mentioned this morning in the discussion. There are also national research funding agencies which play a bigger role. This was also mentioned in another talk this morning, but they will not play a role for the people I'm looking at. So this is what I'm going to address. The personal living conditions of an outsider depend on the individual case. So this is something that does not necessarily reflect the internal structures. I'm more interested in what reflects the internal structures. In the end, I will, as you will see in the one example, I will talk about how this has to do with the kind of mathematics or the way in which the person does mathematics. So examples come to mind. I mentioned those two up there because they are the cases which are different from the ones I'm looking for. For example, Schubert was a professional mathematician in the weak sense that he was teaching at a high school. And by the way, his name is Hermann Caesar Hannibal, as you should all know. And then there is this Ramanujan problem, a very, very special case, which you cannot treat historically without looking into colonial history of India. So this is not what I'm looking at. I'm looking at the essentially 20th century, and I will restrict to 2 Berliners. And the first one, Otto Gr&uuml, I will treat very quickly There is this paper by Peter Roquette. It's not really a historical paper, but it has a lot of information. It starts by this sentence: every student who starts to learn group theory will soon be confronted with the theorems of Grün. Correct, Rebecca? Yes, okay, so everybody who knows group theory knows the theorems of Grün. There are sort of technical things accompanying silo subgroups and so on, but that's not what interests us here. Our interest is in the way he made contact with the mathematical world. And this happened through Helmut Hasse. I mean, he was in correspondence with Hasse. Grün had no training. This is up there in the first part of a short CV that he wrote later on in his life. He had no training in mathematics beyond high school education, but then he actually sat down and read texts about class field theory. This is amazing. And so on the basis of these texts, he got into contact with Hasse. He sends him a paper, and Hasse is not sure. He shows the paper because he recognizes some similarity. Oh, I'm sorry, I'm ahead. I'm going with his first paper. On the whole, he will make a good career as somebody publishing mathematics, not as somebody who has a profession inside mathematics. 29 research papers, in particular, contributions to group theory number 1, 35 through 11, 1964. So this is a long publication career, but the very first contact was about this paper that Hasse, after having corrected the style a little bit, published in Kreller's journal, and after having contacted somebody in Texas, Vandiver, who is another case of an outsider of sorts, but I'm not going to go into this. In a way, in an earlier version, Grün had anticipated, I mean, he was sort of inspired by Fermat's last theorem and sort of how to generalize Kummert's method for primes that are irregular, and then he had hit on something like Vandiver's conjecture, but never mind. This is the details, the mathematical details are not important. I focus on him because he was a Berliner, like the second person I'm going to talk about. And so you just look him up in the Adressbuch of Berlin. This is this wonderful, which is all the Adressbücher, they essentially exist in this form until the Second World War. They are online, and there's this amazing thing. So here you have all the Grüns. There are a lot of people called Grün, and there you have all the Otto Gr&uumls, and then you have their professions: Bäckermeister, Fleischer, butcher, Friseur, and so on, and then Heizer, and then Mathematik. This is the only case I know that somebody is listed with the profession Mathematik, even though he was not a... Okay, anyway. This is the interesting Grün case. He becomes well known because of his Grün's theorems and because of his first publications by the end of the 30s. And so then, after the Second World War, many people come out with very positive statements about him. They try to give him some sort of a teaching position in Würzburg by that time. So in particular, Friedrich Wilhelm Levi, who will be coming up also in my second example. So this is some sort of a roundup of what you try to keep in mind about my first example, about Otto Grün. So why is he so relatively successful in publishing, and also then after the war giving lots of talks giving talks regularly at the group theory meetings in Oberwolfach? Because he manages to attract Hasse's interest. His interests coincide with Hasse's. He has read Hasse. Hasse is the editor of Kreller, and then right after World War II, it is mostly Hermann Ludwig Schmidt, H.L. Schmidt, who will then go to Würzburg, who helps him as well as he can. He is reported to have been a bad speaker and a bad teacher, but his publications are important records. So this is my first example. I chose it because we're here in a workshop that is related to group theory, and because it bears a certain number of correspondences with my main example. The main example is Kurt Heegner, and he, of course, he is also a Berliner, and we are, with Patterson, we are writing a book about him, which is more than half written, but chapter 4 is still to be written, so we are working very hard on this. And this is a family picture from about 1900, dominated by the mother. In fact, the father will die very soon. And you can easily, among the three sons, see who is the mathematician, namely Kurt on the left, the way he looks, can't you? Fritz will become a judge. Wolfgang is sort of the, in German you would say schwarzes Schaf, maybe in English rotten apple or whatever of the family. He becomes, he advises his mother to sell the house just before the inflation after World War I, and then he becomes a Nazi and whatever, and separates from the rest of the family. Never mind, I'm not going to get lost in these things. So a timeline for Kurt Heegner, which I will take you through. So born 1893, all the three brothers that you saw on the picture attend the excellent high school, Askanisches Gymnasium. He graduates in 1913, and then he becomes a student. So he studies mathematics and physics. And the biggest influence is exerted on him by Hermann Amandus Schwarz. He was very old at the time already, but taking care of these beginning students with special interest, directing them to this one paper of Kummer's, his father-in-law, about rational quadrilaterals, which starts with an introduction about Indian mathematics. You may have seen that. Ivan Smadja knows a lot about this. And the other mathematical colleague that he meets through his courses in the first, it was Konrad Knopp, and that became important because of the later connection to this Mathematische Zeitschrift, which would be founded by Knopp and others just after World War I. Saying World War I, this is what interrupts his studies. In June 1917, he's called to the army. He absolutely doesn't want to do any fighting or whatever. He tries to get into meteorology. That doesn't work, but then the family arranges for him to be in a radio engineering unit, and he continues to work there, and this results in a thesis. So, of course, this thesis is not in mathematics, but in radio engineering. It's about valve oscillators and has this beautiful German word, Zwischenkreisröhrensender, you know, the German languages. Okay, anyway, so he manages to get his doctorate. This is in Jena, because there's nobody in Berlin. And the oral exam is not very successful, but then he sort of has a profession, doesn't he? I mean, he's sort of a radio engineer, and he publishes, these are just the papers he publishes in this very well-known journal, Zeitschrift für Physik. He also has a few more papers in the 20s and a few still in the 30s in more applied engineering journals. He is a member of the Deutsche Physikalische Gesellschaft, so this looks like the beginning of some sort of profession. By the way, these off-prints, we have been talking yesterday about off-prints, they are from Carl Ludwig Siegel's collections of off-prints, which was given to the young Max Planck Institut für Mathematik in Bonn when it had just been founded and the library was in bad state. They are still in the Max Planck Institute, but not in the library. They are in a locked closet in one of the offices used by thesis students at the Max Planck. Anyway, so here is Heegner in 1935 on the terrace of the apartment in Steglitz that he would live in with his mother at that time, as of 1932. And so it looks like a great career. In fact, it gets even better. He has patents for his oscillators. And during the war, they get built. This is the I mean, it's hiding in this black box there. They get built into the Befehlspanzer. So these are command tanks of the German troops. So this brings in a lot of money. So here you have genau 2000 Reichsmark that he receives in 1939, and altogether he receives a little more. And even today, a two-valve version of this Heegner oscillator, this is a very recent website of Axtal, is being used for very high precision thermometers and so on. So if you look at that, usually Heegner is not at all presented like this, but if you look at that, it's the beginning of a great professional story, right? He is a successful engineer and even making money, at least in wartime, whatever you think of it. And okay. Yet, this is not the whole story, and he keeps being interested in, well, first of all, his job with Telefunken, where he had been working in this laboratory and constructing his oscillators, is a half-time job, and it's not continued after October 32 for whatever reasons. And so, but even before that date, he begins to remember more and more intensely what he has learned from Hermann Magnus Schwarz and deals with mathematics, and so he finally submits, just like Otto Gr&uuml, a first paper to Krelle's journal. Well, he sends it to Hensel, who is still the official, but Hensel, because it's, well, Hensel sends it to Hasse, his former student, and so Hasse doesn't know what he sends it to Hecke for a review, and here are some abstracts from the review. Heegner's work is rather difficult to judge. On the whole, my impression is he understands things and has a reasonable idea, but the presentation is horrible, incompressible, crucial places where he gets equation 2 from the heart of the matter and how it comes about is not set, and so on and so on. He has the same cumbersome way of expressing himself as Fricke. Now you understand why I asked you about Fricke this morning. Fraught with many perfectly superfluous neologisms. I think if the paper is accepted like this, you will rear a Fricke index 2. So this is sort of the worst thing that a reviewer Hecke can tell Hasse. So what does Hasse do? With Otto Gr&uuml, he would just be in correspondence and correct this before publishing it, but here Hasse doesn't feel competent. So he calls upon the guy who wants to be his assistant at the time. It doesn't really work out because it's ill. It's Erich Besselhagen. Besselhagen has a family in Berlin, so over Christmas he is in Berlin. And so Besselhagen reports about his relations with Heegner. So during the Christmas holidays, Heegner came to see me 3 times, and we spent a lot of time brooding over his manuscript, but without coming to a conclusion. He is a shy man, seems physically weak, and works on his mathematical projects in his spare time, which I find worthy of all appreciation. I heard through my cousin, who has a high-ranking position in the patent office, that Heegner's colleagues at Telefunken call Herrn Heegner the wireless Christ, drahtlosen Christus. At least some of you laugh. When I gave this talk a few years ago at Penn State, I was told that this was inappropriate to quote such a thing. Okay, anyway, let's go on. So here are his first mathematical publications. He does get a paper in Krelle. It's a far cry from what he first submitted, and we have no evidence of how this transformation over a period of 1.5 years happened, how much Besselhagen has there or other people. We don't know. And it's even harder to read than the original version. But what is more important, so the other things are in Mathematische Zeitschrift, contact through Knopp, whom he had met as a student. And in particular, there are these 3-part papers which bound together make his Habilitationsschrift. So applying for a Habilitation at Berlin University was something too difficult for Heegner, so it was again Besselhagen who did the formalities for him, but it worked. And he does pass. He passes rather well, in fact. Bieberbach at the time was the dean. Well, I'm not going to go into it. Erhard Schmidt was on the committee, and the big Nazi Werner Weber actually made the oral exam about number theory, quadratic forms, and so on. Okay. Anyway, so he now has some sort of a title. He is Dr. Habil, but the Nazis, in reforming the university politics, had changed the nature of habilitation in Germany, the second degree. Namely, you do not automatically, by passing the scientific requirements, get the right to teach courses. This would be another thing where you have to go through a political training camp and so on. He applies for that, and this ends nowhere. He never gets the right to teach courses. So, but at least he has this degree, Dr. Habil. During World War II, his mother dies, and then comes the same story if I may say so, sort of shortening things very much, as with Otto Gr&uuml right after World War II, he is also in contact with these Berlin mathematicians like Erhard Schmidt, whom he knew through his habilitation, Hermann Ludwig Schmid, who would afterwards go to Würzburg, who was so instrumental in helping Otto Gr&uuml, and other mathematicians there, because he doesn't have enough things to heat his apartment, and the house of Erhard Schmidt, which served as a temporary home of the Mathematics Institute after the war, was very close from this house in Steglitz, so he went there to warm up and talk to the other mathematicians. So this was sort of a way of getting into it, and he even gave a talk on the 23rd and 30th of April 1946 in the Mathematical Colloquium at the time about Kummer surfaces constructed from hypersurfaces. The context is also for this, in Heegner's mind, is arithmetical, but I have no time at all to explain this. So thanks to this post-war Berlin local, micro-local situation and this context with this contact with the other mathematicians, he gets a position as an assistant at the Academy of Sciences. This is East Berlin, but at the time there was no wall. You could live in Steglitz and just go to it. So he has to submit an application. This is a picture submitted with his application at the time. Doesn't look quite as well as he did in the middle 30s. And in the mid-30s, and then this doesn't last very long. In 1950, Hermann Ludwig throws him out. He never informed the Institute about his work. He never was even seen. He even picked up his salary late. So not very successful. Okay, so then come the 1950s. He is really poor. He's really suffering, but somehow surviving. But then he, maybe also due to talking to these mathematicians, he finally, for the first time, publishes a paper where he brings out what he really wants to do, even though he doesn't say so clearly there either, but it's much closer to his internal research program that he must have had since his student days, the 1952 paper in Mathematische Zeitschrift. So in particular, there are two claims in there. I'm not going to explain this here in mathematics, but it's the Gauss class number 1 problem and a certain result on congruent numbers. Congruent numbers are integers that are the area of right-angled triangles with rational sides. It's in this sense congruent numbers. And it's well known that this congruent number problem is related to rational points on a certain elliptic curve, which I've written down there, if the congruent number to be tested is p. And he says that for p congruent to 5 modulo 8, this has rank 1. So, so these are very strong results, and so normally you would think that people would have paid attention, but the success is not so great. The successor of Hecke in Hamburg, Schöneberg, writes this little review where he says, well, I should be remarked that there are several places where the referee cannot follow. So the usual story that is being told about Heegner is this. So there is this 52 paper. There is another paper, 56. The 56 paper appears in Mathematische Annalen. We have tried so hard. If any of the historians here can help me, I would be really grateful. We have not been able to find out who was the reviewer, where are the corresponding files from that period, 1956. The Behnke-Nachlass does not cover this in Münster, and so we just don't know who reviewed this. There will be an obvious hypothesis coming after what I will tell you in the last part of my talk, but anyway, we don't know. But this is the one and only paper in Mathematische Annalen that he has placed, and it's worse than the 52 paper. It's not only written in a strange way, but it's very hard to grasp what he really wants to do. But in the very end, let me just say it like this, I don't have the time to go into detail. At the very end of the paper, he goes back to the first problem that Hermann Amandus Schwarz gave him as a student, and so there's this long way from the problem of rational quadrilaterals or tetrahedra to the analysis with Hermitian modular forms. Okay, then in 65 he dies, again, this is the usual story. You see there's a hole which I will fill, but then he dies, and then in 2 years after his death, Harold Stark from California proves the class number 1 problem, the first thing that Heegner claimed he did in his 52 paper. And at the end of the proof, the same little Diophantine equation occurs that was also at the end of Heegner's proof. And so then people suddenly wake up and start looking at Heegner and say, okay, there are little lacuna, there are things that are not, but it's easy to fill them out. And of course he was right. So Deuring, Karl Ludwig Siegel, Kurt Meyer, the Klassenzahl Meyer as he's called in German, and Schauler published papers on this. And so then it's clear that Heegner did it. And not only did Heegner do it, but there is in particular one British mathematician, Brian Birch, who really delves into the 1952 paper. He spends months and months fighting with it, and out of this comes the notion of Heegner points, which starts a new era. Mentioning Brian Birch, just to pick up on Fricke, my favorite mathematician today, David, one may distinguish 2 approaches, says Birch in a general introductory talk in the very famous Antwerp conference in 1972 about modular forms. Ideally, one might wish to use nothing more than geometry of upper half plane modulo gamma 0 of n in the spirit of Klein, and more specifically of volume 3 of Weber's algebra. In practice, one is driven to use every dirty trick one can lay one's hand on after the manner of Fricke's algebra. Okay, so you have the same thing even echoed there. Let me get back to this. A new structure. This is a conference on structures, right? A new structure called upon Heegner in 1958, and this we found out a few years ago, but it is relatively new. The thing is, we had in these papers, we had this thing that he wanted to type as a letter, and then there were typos, and then he used it to do mathematics on the back of it, but we still have it here, and it's addressed to Sehr geehrter Herr Professor. That can be many people. So we didn't know, and there's also a mention of Levi, the same Levi who wrote this good evaluation of Grün and so on. So we didn't know whom it was to, but then after looking around and after contacting the Institute for Advanced Study, it was André Weil. So André Weil, and now we are preparing for Bourbaki, right? Except that here is Weil not as Bourbaki. André Weil was the one who invited him. Professor Weil stated that he wished to devote his assistant fund for 58-59 at the Institute for Advanced Study for Hisashi Morikawa and or Kurt Heegner. He will let the director know of his decision. And there is a letter from Weil to Marston Morse, also in the files, where he explains this, and then should Heegner, who is obviously an old man with a peculiar temper, still express a wish to visit Princeton, I should still be in favor of our doing something for him, inviting him the next year. So essentially, Heegner only answers 1 out of the 3 letters that Weil writes to him to invite him, and because he's not feeling well, because he feels old, he is not picking up this occasion, and the dies relatively soon, 5 years after this. So the problem now, and this is a new structure because the Institute for Advanced Study, as I mentioned before, is a new type of institute that didn't exist in earlier periods of the history of mathematics, and it offers something to Heegner, even though he is not in a position to pick it up. But why? What did Weil know about him, and what interested Weil? So there, a lucky coincidence, Jean-Pierre Serre contacted me because he knew I was interested in Serre and sent me, Serre is well known for many things, Jean-Pierre Serre, but maybe the very best thing is his way of taking notes of lectures that he listens to. So here is a lecture, La Juste Weil, so it's a talk given by André Weil. In Nancy, it says Nancy, the date 1954, Serre added later on. This is interpolated. It was not dated originally. So the idea is it was 20 or maybe 21st of June, because on Sunday, June 20, 1954, Bourbaki had an emergency meeting in Nancy because of this terrible affair, the the fight between Godemont and Leray and the new position for Chevalet. I mean, things were really escalating, and so they thought we have to get together and talk. So the Bourbaki people were in Nancy, and on this occasion they came to Nancy. Serre was in Nancy anyway because he was maître de conférence in Nancy at that time. He was not yet professor at Collège de France. And so here Weil gives a talk. He gives a talk about his work, about what he does, zeta functions, first zeta function for curves over finite fields, and then zeta functions for, in particular, elliptic curves over a number field. So Serre takes notes, and then comes the last page of Serre's notes, 6th or 7th page, and this may not even be part of the talk of Weil, maybe it was the discussion afterwards, but anyway, this is what Serre writes down. See also Heegner, amateur, doesn't say outsider, who seems to imply that many elliptic curves can be uniformized like this. Take a ternary quadratic form over a totally real number field. Suppose it is positively linear at all realizations but one, where it is of type 2, 1. Look at this last place. This makes a Fuchsian group with compact quotient, if you let it act on the upper half plane, no cusps. He looks at curves which may be uniformized by that quotient. So Tony, how does one call these curves today? No, you don't call them Heegner curves, you call them Shimura curves today. Shimura curves. This is not the usual way that one parameterizes elliptic curves today. Well, first of all, let's look at his 1952 paper. There is, at the beginning, there is the fundamental, second page, the fundamental idea of my paper is to apply Felix Klein's theory of modular functions to different levels of transformable automorphic functions. And he refers to his habilitation that I showed you. And in this habilitation, if you really take the time to read it, which apparently André Weil has done, there is exactly this group described that we have in Serre's notes of André Weil's lectures, and even at the beginning, I go quickly, there are sentences in German which, if you know what he's talking about, you can understand. If not, you have to guess, but it really matches up with what Weil says. So now, this talk in Nancy happened, probably in June, but anyway, in the year 1954. A new structure, excuse me, that emerged after the war and after the refoundation of the International Mathematical Union, and thanks to the fact that at that time there was a UNESCO attached to the UN, which was very well thriving and had lots of money, there were these international conferences staged. And one of the most noteworthy and conferences of lasting importance was the meeting at Tokyo Nikko. And here you have a picture. So Tamagawa on the left, then Serre, and then Taniyama and Weil in the train from Tokyo to Nikko. And the person, Shimura, whom I mentioned before, you don't see because he's taking that picture. So, so this is all this, and this was this enormous conference where for the first time there was a problem paper by Taniyama circulated among the conference participants, asking the question whether it wouldn't be possible to parameterize all elliptic curves by modular curves, but not by these Shimura curves that you have seen in Weil's talk about Heegner. However, at that time, the people thinking about this was very new at the time, but all those who participated at this conference and others who participated in this new movement, in order to create the link between the things you want to parameterize and the things that parameterize, they look at zeta functions or Mellin transforms of new forms, whatever. And these zeta functions are completely absent from Heegner. That is, Heegner does not have a general theory in mind. He just, at certain points, postulates this. The funny, it's actually very sad, it's not funny. Goro Shimura has written sort of an autobiography, The Map of My Life, published in 2008. And he talks about Fricke's investigation, which showed that the action of the groups properly, and so on and so forth. And then he makes a comment about Heegner's habilitation in 1912, which is all. And then he quotes Heegner. And he quotes 6 is, again, the habilitation paper. The very paper that gave Weil, according to Serre's notes, the idea that Heegner wants to parameterize elliptic curves by Shimura curves, as they were not yet called. And he says, he just quotes it, which I cite here in order to show that the topic was not forgotten, but being treated without any new ideas. He missed that. Anyway, later on, of course, this parametrization of elliptic curves is very important. You have the picture of Andrew Wiles giving the talk, and then you have, I took this picture this morning, when you go out and look upstairs, you have the original blackboard, where you can see that E, the elliptic curve, receives an arrow from x naught of n. It is parameterized, and it is a modular curve. But it's a modular curve in the sense of x naught of n, so Klein, and not at all Shimura. And so Wiles had the idea of how to prove it, and it was generalized, so all elliptic curves over Q are parameterizable by x naught of n, Taniyama-Shimura conjecture, as some call them, and then you can translate this to Shimura curves and fulfill Heegner's dream. I have gone a little bit over time, so it's time to stop. I just show you as a very last slide one more Fuller quote from the introduction to his famous 1952 paper, where again, I mean, if it's a literal translation from the German. If you read this, no modern mathematician readily perceives what this is all about. But in fact, what he means, the resolvence according to which coincidences of the infinitely many transformation correspondences is what today is called an eigenform of the Hecke operators. And we're back to Hecke, and I'm coming to my end. Thank you very much.
Yes, thanks so much for enlightening us on an outsider. The floor is open for questions. David.
And yeah, quite spectacular story. I thought maybe to say something that's come up in other talks too. I don't know if there's any really decent historical literature on on journals and how they're handled, the publications in them, the refereeing process, etc. And it comes up in your story there, and where you see something quite specific that's going on, but I think it's within the norms of behavior after World War II. The papers are refereed by people who are experts on various things. That was not the case for a long time. And so Erich Hecke was in fact the editor of Mathematische Nachrichten during that time period, which
No, that was before, but not in
wrong?
the 56 paper. He wasn't there anymore. No.
Oh, it's 56 that he. Oh,
his Mathematische Nachrichten paper was only 56. The first was Krelle, and the other Mathematische.
I thought it was 46 that you showed. Maybe I'm mistaken.
Typo.
Well, the story you told about, yeah, let's go back and look. It's always better, get the facts straight. Maybe when the paper is sent finally, well, he's the one who writes about Fricke and so forth.
No, but that was his first paper in 32.
Oh, it's already in 32?
Yeah, that was the very first thing he submitted.
Okay, I screwed up the dates pretty badly.
Yeah.
Okay, Hecke is not yet.
So,
he's not
in
yet.
fact, 31, but yeah. 30, sorry. Yeah.
At any rate, okay, so this is, what I'm asking about is there any decent historical literature about things like how the editorial process actually work with these mainstream journals, which take on a certain norm at a certain point. I think they've now radically changed when we have this proliferation of journals today and all the e-publishing and everything. But it's in order to evaluate, you know, to what extent this is a normal process or whatever, you had to have a context for what typically happened when a paper was submitted. And this is a special case, obviously. I don't want to generalize from any special cases, but I'm not really aware of too much other than the stuff I wrote myself about mathematische Annalen and Otto Gr&uuml, but that's an earlier era, of course.
Yeah, okay, so I think a certain amount of things are known, but, and it depends on the journal and on the time and so on, many individual studies. The general problem is that, that the refereeing things are in personal papers, and I often encountered the situation where somebody who is old and he wants to give his personal papers to an archive said, but not these referee reports, because they're afraid that they would be read through, or I don't know what they're afraid of, but I mean, I've heard this more than once. I don't say the names now, but, and this is, so here, how do we have this evaluation of Heegner's first submitted manuscript by Hecke? It's because in the Hasse-Nachlass there is a whole part, Krelles Journal, and so you have all the correspondence related to Krelle in the Hasse-Nachlass in Göttingen. But it's just by chance. I mean, and so who knows? Maybe somewhere these things related to mathematische Annalen in the 50s still exist, but maybe not. And it generally, I think, well, I mean, others may have had similar experiences, but it's really difficult. I mean,
I can comment too. I mean, Krelle, of course, is the oldest journal and has this kind of special tradition. But Mathematische Zeitschrift was the first Springer journal, and it had young people on a big editorial board. And I think it looks very much to me like that's the first really modern professional German journal.
yes, but for the Mathematische Zeitschrift and the famous 1952 paper of Heegner, we have his correspondence with Wieland. And this is interesting, I didn't mention it because I was already going over time, but I mean, Heegner insisted that when this paper was published, he wanted to have a quotation from a Bach cantata. And Wieland said, well, you should be happy to have it published. Come on. It's not all right.
Jeremy.
Yeah, I spent a miserably small amount of time trying to read things like Kleinfricker.
Yes.
And I decided I didn't have a good reason to proceed, and I probably wouldn't succeed if I did. So it turns out, I'm not sure, all this kind of later Klein stuff. Being now studied by people who know how to rewrite it and reinterpret it. And has that ever been looked at properly? I mean, do we have a story about how these people reformulated these other, I would, obscure ideas, I would say, and certainly not expressed in a 20th century fashion?
Okay, this is thank you very much for this question. It's a big project. The answer is not of the sort, yes, this has been sorted out by this or that person. No, it hasn't been written yet. It is, Fricke in many ways is picked up in the second half of the 20th century, but sort of for certain, with a different viewpoint, with a different language, and it really is a big change of the way of looking at things and the way of writing things, which takes place. And still there are, maybe less in Fricke's books that Heegner was studying, but in some of his papers in particular, also one of the last papers that he wrote. There's enormous amount of work to be done. I mean, the very big project that I have in mind is sort of an enormous research project about how the 20th century dealt with the moduli and the modularity inspirations that the 19th century gave to it. But I may have mentioned that yesterday already, but it's an enormous project, and even in my mind, it doesn't have very precise contours yet. So it's but I thank you very much for this question, because I do think it's a challenge that historians of mathematics who know some of this mathematics should really tackle as soon as possible. Yeah.
One minor detail and one more informative detail. You mentioned the date of his mother's death. Did he have a family of his own?
No, nothing. No. He lived with his mother until she died. Yeah.
The other question. So apparently, despite the interest that they has in Heegner's work, the rest of the community doesn't pay attention until Shank's article comes out.
Starks,
I'm sorry.
Yeah.
Right.
That's right. It seems that way. I mean, the big question mark, which probably will remain a question mark forever, is what Carl Ludwig Siegel thought about all this. Because I showed you, well, I only showed you the physical, I only showed you pictures of the reprints in the physical journal, Zeitschrift für Physik, but I mean, Heegner systematically sent off-prints of his mathematical papers, in particular, to Siegel. And Siegel clearly knew about him, and so these papers are in Bonn, so I looked at them, and in the Habilitationsschrift, because it has some relationship to Siegel modular forms that he was, to things that Siegel was thinking of a little before or almost at the same time. So there are a few little pencil marks. We talked about pencils yesterday.
What color?
A few little black. A few little pencil marks in this, but as usual with Siegel only correcting misprints and no other commentary. So at least these habilitation papers Siegel did look at. And it is not impossible that André Weil learned about this or was his attention was attracted to this paper by Siegel, because Siegel and Weil were in contact. Of course, it's completely possible, but we cannot prove that. And the fact is that until Heegner's death, as far as we know, Siegel never did anything for Heegner to sort of help him or put him on track or whatever.